So before I get to the hardware that I've got here to have a look at, I just wanted to go through a couple more things that could be construed as electronics, I guess, which they are electronic devices, but they're to drive hardware that I have. And to start with, one of the things that I've been doing the CNC project for is not because I necessarily wanted to have a CNC, although that in itself is kind of exciting and I look forward to playing with it, but more I wanted a platform to be able to demonstrate motion control solutions, and how you interface an Arduino to some motors and what the implications are, and all sorts of things, and how you make and create displays to go with motion control. And it could be a CNC, it could be a 3D printer, it could be a laser cutter, it could be a plasma cutter. It really doesn't matter what you put as far as the cutting or moving part of the motion control system is, but the key thing here is that it involves stepping motors, DC motors, linear motors, actuators, limit switches, and a whole bunch of other analog things that I see all the time people trying to connect to their Arduino or their Raspberry Pi or some other microcontroller. So that's why I started the CNC project, because it actually acts as a great platform to demonstrate a lot of those capabilities. So in that vein, one of the first things I was going to do, or not was going to, but I am going to do, is a video on motors. All right. Now I have a whole boatload of stepper motors and things like that. So I've been collecting some over a while. I got this box full here. Not all of them will go in the box, because I've got one which I'll grab because it's really kind of cool. This is a rather huge stepper motor. This is actually what they call a NEMA 34 stepper motor, and it's massive. It's way bigger than I need for my CNC, that's for sure. So that's a big stepper motor that I've got. And I have other stepper motors. I've got the NEMA 24s that are on my CNC out in the garage, which I will show pictures of. But I also have some smaller stepper motors. These ones have been retrieved from printers that I've stripped down in the past. This is another stepper motor which actually came out of my i9900 printer that I stripped down about a week ago. So that's actually a bipolar stepper motor. Got DC motors. These ones came out of a printer as well. They didn't come out of the i9900, but the ones that are in that are pretty much the same as these. I also have some, now these are technically servo motors, so these are the kind that you would expect to see in a remote controlled airplane or RC car or something like that, and these can be very useful for projects. So we're going to look at how you would drive these from an Arduino and a Raspberry Pi and things. And then I've got a couple of those. And I've got, like this, I think this is probably would classify as the, nope. Yeah, so a bunch of different stepping motors. I've got 6-wire stepper motors, 8-wire stepper motors, 4-wire stepper motors. And what I've also got, though, is a, oh, here's one more motor. Now this is actually something I just found the other day. I was at a place called Princess Auto in Ontario. And this is actually a door lock mechanism for a car. And it, it comes up and will open the door and go down, it will lock the door. But this actually has a motor in it as well. So this is something that you might call a linear actuator, where you use a motor or pneumatics or something to drive effectively a piston out or in to make some kind of motion. But either way, when you're doing motion control, it doesn't all have to be rotary. Even when you're doing rotary, often that ends up in a linear motion. So this is what you might call a linear actuator, where it's only a few inches of travel. On a CNC, you might be rotating a stepper motor hundreds of turns, but that results in a linear motion of, say, a meter or something across a piece of aluminum rail or something like that. So the other thing I got in here is a bunch of different stepper controllers. Now this particular one here is for a launch pad. This is a Texas Instruments stepper controller. It's their booster pack, stepper motor booster pack, which I have, which will hook up. This one is a full, all you do is you can talk to it through I2C, is it I2C or SPI? I can't remember which, but anyway, you can talk to it over a serial protocol and tell it what kind of current limits and speed and things like that to go and drive it. Or you can talk to it with step and direction kind of commands to a stepper motor, and it'll handle quite a different range of motors. I also have a couple of Infineon motor controls. Now these are effectively a half bridge, but one of the nice things is that's effectively a half bridge, or for driving two motors. It's an Infineon, and it's got quite powerful. You can drive some very, very big motors with this. And I've got two of these, so these would also technically be able, if you run them both together, you could technically drive these as a stepper motor driver as well, by using the two as a half bridge for one for each coil. I have some chips coming from TI, which also are stepper motor controllers. Some of them are full, where you give them a step and direction for driving the stepper motor, because if you think of a stepper motor, they've got 2 coils or more. But if you think of the basic 4 coils, you can either energize the coils directly using a stepper driver, which is often referred to as an H-bridge, and you'd use 2 full H-bridges to drive a bipolar stepper motor and make the rotation happen. But you have to drive them in a special way with phases. And I had one of the members on the community forums that I help with that were asking about how to control a laser harp using a stepper motor and things, and he was having a little bit of problems trying to make that work. So I've been trying to help him, but I think the easiest way is to actually build it up myself and have a look at what's happening with the code and everything else, and I think that it will make a good video for other people. And my cat's down here whining for attention. Yes, the door's open. Go on. I'll be right back. I think the door's closed to my lab, so she can't get out. Well, that was the issue. She couldn't get out of the lab, and she wanted to get up to her food and things, so she's happy now. Now, what was I saying? Oh yeah, so that's a whole bunch of stepper motor controls and things. But when I was up at SNB Solutions the other day, he also, Sam, who owns and runs SNB Solutions in Barrie, Ontario, he's the guy that I've linked to that is sponsoring me for a lot of the CNC hardware, things like the linear aluminum V-rails and end plates and gantry plates and all sorts of things like that. And when I left, he actually gave me some TinkerForge USB stepper motor controllers. These are little USB controllers. They've got a microcontroller built right onto the board, stepper controller, and these things, you can actually stack them up on top of each other. You can put a master brick in there. You can add sensors to them and things like that. You can expand them in all sorts of different ways. So he gave me a couple of the USB-based TinkerForge stepper bricks to play with, and to show people how to use them as well. He actually supplies these, and so you can order them from him if you want. And they actually, I think, also have Microsoft stepper APIs and things, so I think they may even be Microsoft compatible. But anyway, I've got 2 of these to play with. They won't drive big stepper motors, but they will drive stepper motors up to maybe a couple of amps at up to, say, 30 or 40 volts or something like that. So they'll be interesting to play with as far as part of the stepper motor control evaluations that we do. And then the other thing that Sam gave me, and this goes along with the more of the CNC control versus just general stepper motor control, is a new controller board. Now, if you look at the videos that I've done for my own CNC, you'll see that I've used currently an Arduino Uno to take G-code coordinates and convert them into step and direction pulses for up to 4 stepper motors that are connected to my system. And what Sam provided me here for this is actually a controller that comes out of China, which is the Mach 3 motion control card. It's a WXHC motion control card, and this is a 4-axis CNC. It's built to actually work with Mach 3 software controller card, and it doesn't drive the stepper motors. It interprets the G-codes that's coming from your design tools and your CAD tool, and then will generate the step and direction pulses for the 4 axes as well as the spindle. It'll take 24 volts as its supply right in. All of the inputs and outputs are all optically isolated, and that includes the USB interface. So you've got virtually no risk of doing any damage to your computer if something went wrong on the stepper side of things, or your 24 volts you got connected wrong. It's the USB has USB isolation chips right in there, and I've got some high resolution pictures that I've taken that I'm going to be using when I do the video for this, and we're going to hook it up and see how well it works. It's got multiple inputs and outputs for e-stops and limit switches and all that kind of stuff as well. So I look forward to sharing and doing a video on how to hook this up and get it all working. Okay, now we're on to hardware. Sorry, kind of leading into a thing here. So the other thing when I was up at SNB Solutions was I was talking to Sam, who, as I say, runs the place and owns the SNB Solutions, about the fact that many of my viewers were commenting that because I was using 80-20 and 60-20, that's the dimensions of the extrusions, for my X and Y gantries, that because I'm using 1.5 meter long lengths, there may not be enough rigidity in that length to allow me to have nice accurate cutting on anything more than maybe some of the softer woods, because of the pressures and the forces of momentum with the motor and various other things. It would actually flex as it was trying to cut and things like that. So one of the things that Sam at SNB Solutions has recently introduced on his site is a whole range of new plates and extrusions, and he's calling them the Rover Ox parts. So when you look at his site, look for Rover CNC parts and things, and you'll recognize them because they're all beautifully red anodized aluminum. Now this is actually, would you believe, it's a foot for the CNC. This is massive, right? If I bring that in a little closer, and what it is it actually sits the way I'm showing you right now, and you have a C-section of extrusion coming towards the camera off of this side. So it would be the top 2 screws, all the ones down this side and a couple at the bottom here, and then you have another extrusion which comes in from this side that would slide in over these T-nuts and be bolted, and it would go partly into the C-section of the extrusion, and I'll link in some pictures when I actually do the post-editing in this. And you can see the thickness of this. Even the thinner piece, you can see it gets wider here. The thinner piece is over 6 millimeters in size, and the thicker piece is over 8 millimeters thick. This is built like a brick, all right? It's not going to move. And the other thing that is here is, even though your extrusions are up here, if you want to use a ball screw or an Acme screw for this, it's already got the capabilities on the end of each foot to mount either a NEMA 24 or a NEMA 34 stepper motor, or you can mount a NEMA 24 compatible servo drive, which Sam also sells on his website. So you'd have the bearings in here. You'd have, you'd put bearing mounts in here for the drive shaft to go through the thread, and then you'd have some standoffs, and your stepper motor would be standing out here a little bit. And you'd put one of these in each corner, and as you can see, these are really, really substantial. And as I say, when I do the video, I'm going to link in here-ish a picture of what I actually have currently supporting the corners of my CNC, if you haven't already looked at the videos, and you'll see how much more substantial these are, and therefore how much more rigid the build is going to be once I replace them with these. And that's just the feet. He gave me a lot more. The next part is for the X gantry, and what Sam gave me for this is a new back plate, which this one is pretty much the same as the one I currently have on the back, which is this one. Again, nice beautiful red anodized aluminum sections. The sides are beautifully smooth and everything else, very high quality machining, but this is the front plate for it. And the one thing, if I don't have the other one to show you because it's out in the garage mounted on my CNC right now, is my current plate only has 3 mounting holes for the wheels for the Z-axis that goes up and down in front of this. This now has 4 on here, all right? So you can actually mount an extra wheel, which is going to give you a lot less chance of this happening with your Z-axis when it's coming up and down on here. All right. Now this is a direct replacement for the ones that I currently have on my CNC, which has a 60-20 extrusion that comes up and down here. All right, and your Acme nut block screws to this, and then everything screws up and down above that. So that's for an 80-60, sorry, a 60-20 Z-axis coming up and down here. So those two nice upgrade replacements, very high quality. It's going to look really, really cool having these red anodized plates and everything else on it. The other part that Sam gave me is a pair of Gantry extrusions. Now these ones, they look, when you look at this, they look very, very similar. And I'm going to grab a picture. I put that one to that side there. I'm going to put the other one over this side so you can have a comparison. And so this is basically the same as what I currently have, in that you've got the wheels screwed here. I'm deliberately just showing you this side for the moment. You've got your stepper motor goes in here with your mounting, and you've got your little bit of adjustments. And then your X gantry comes on here and actually comes towards me to the other side, where you have a pair of 60-20 extrusions up here, and then you have a 20-40 extrusion mounted here for a bit of extra support, and then these are for your cable exits. And then you can put some little extra angle brackets on here so that you can improve the rigidity. But one of the things that we're also looking at with Sam is actually adding an extra slot and hole on here so that we can actually use a full 80x40 extrusion, which means it's going to be much, much more rigid when you have a 1.5 meter span. And I don't have that on here, but what I'm going to do for this one, once I get the relevant X gantry plates, the ones I just showed you are for 60-20 in your vertical, and they won't take an 80 and a 60-20 in the horizontal as well for the Z and the X axis. I want to be able to use 80-40s on both of those axes, so I'll need a little bit of a modification to some of the parts. But I'll drill the extra holes in here so that I can actually mount that 80-40 plate going right across. But the other part of this, if I turn it around now, is it's actually got two sets of wheels. The ones I currently have only have one set of wheels, and I only have a single 80-20 rail going front to back on my CNC, and this allows me to use an 80-40 rail C-section, which is going to be much more rigid, and because you've got more wheels, it's going to last a lot longer before the wheels start wearing out and needing to be replaced. The other thing about having the extra wheels too is it's going to be keeping its accuracy a lot more, because you do have more surface contact with your rails. And lastly, with that extra width, is this X plate that's on the inside, which will actually keep the rigidity even more by having it solid on both sides of the plate. So your 80-40 will be running inside this hole right through, and this is going to prevent, at the moment they're just this first set of nuts and then a bolt sitting here with nothing else. Now it's going right through, and the bolt is actually being connected to this nice strong plate. So that gives you a very, very robust gantry, and this is going to work quite happily for smaller machines where you don't have a 1500, 1.5 meter span on your X-axis. As I say, that's why I want to increase this to be able to take an 80x40 plate so that we can have the 1.5 meter span and it have to be still rigid and everything else. So that's that, and I've got one more piece to show you here. Okay, the last thing with the CNC hardware is a new Z-axis. So the one I have right now is based on using a standard piece of 60-20 extrusion, and it's about 12 inches long. It still has an 8mm Acme thread on it. And what this one is this one's 15 inches long, so you got the extra height. Now the plates that I showed you before, one of the things I forgot to mention with those, that's these Y gantry plates, is that these are actually 2.5 inches taller than the previous ones as well. So there's a lot more gap here, so you're actually higher up on the gantry. Anyway, with this Z-axis, this is the one that's going to go up and down with your motor mounted to it and things like that. You can either mount it this way, where the side that's facing me is bolted to the X-axis and it goes like this, and then you put a plate on here with the motor mount on. So, a little plate like this might be mounted over here, and you put the motor on there and it'll go up and down. Whereas if you chain it around and you mount this side onto the gantry, then you could screw this all the way up to the top where it's the same height as the gantry now, which means you could have maybe something that's almost 12 inches tall for maybe doing some carving in 3 dimensions. And of course then the gantry, the Z-axis can slide all the way down, like the full, it's probably going to be about 12 inches once you factor in the size of the plates and things like that. So you can have quite a range of motion for the Z-axis. And then if you were going to cut aluminum or something, you might want to put a riser, raise up the height of your cutting surface, maybe with an MDF platform or something securely bolted, and then lift up your Z-axis so that there's a lot less bending forces going on at the cutting end. Okay, but anyway, this is the new Z-axis, and as I say, it's 15 inches long in total. So I've got to work out how to mount that, and that's why those X gantry plates, they're not designed for this size of Z-axis. They're designed for the 60 by 20 extrusions on it, which is the ones I currently have on my platform. But that's all of the hardware now that Sam had provided to me. I do have, I want to show you some of the extrusions that he gave me as well that go with this, and how some of the plates mount to that. And so we'll go to that in just a second. Anyway, this is looking at the extrusion with one of the feet put on, and you can see here this is the 80 by 40 extrusion, and it's a C shape. I'll actually bring one of the other ones and show you the end section of it. So this is the end section of the 80 by 40 extrusion. As you can see, you've got the 80 section here, and then with these extra pieces that are on, you've got the full 40 width, which is adding a lot of rigidity, and it will inhibit it from twisting anywhere near as much because of this extra. And one of the things you can also do, say if you're putting this on an X or a Y beam, if you really want to stiffen it up even more, is put a 40 by 20 beam inside here along with this, if you really wanted to. Now if you're running a screw inside of here, which by the way, when you're using these feet, as you can see down here, that's the foot, so it would be sitting on the floor like that with the extrusion running along. Then you wouldn't be running your ball screws obviously inside the channel here. But depending on how you configure this, and if you do get the these feet, then you're obviously planning on well, potentially running it with the Acme screws. Now in my case, I'm still going to be running belts on the top. But one of the things I was talking to Sam with was even the possibility of having dual belts on here to improve things even further from a stability perspective. Anyway, that's the end of the extrusion there, and that's one of the feet that's still screwed onto here. So you can see, and then the extra beam, and I'll include some pictures as I go through, will actually sit right in this channel. You use a 20 by 40 beam in this channel here, going off to the left from the way we're looking at it right now, going across the other side. And because that's such a precision fit, it makes for a very, very accurate 90-degree, keeping these things parallel to each other as well as perpendicular to each other, to make your whole frame for your CNC much, much more stable and accurate.